This video course is a part of LearnSD project, which is an interactive web platform for learning sound design. You can do things like that there. Or like this. You can also follow our Max4Live course on LearnSD website and get even more information about every lesson. The whole project is just starting, so it is really interesting to hear your opinion. You can write it in the comments to this video. Hi, I'm Tim Shatny. We continue to improve our Max4Live device which we built in the previous lesson. What we did is a simple gain audio effect for controlling the volume of a signal, which works like that. So with this gain knob, we just changed the volume of the signal. But we discovered one problem here. If we try to modulate this gain control really fast, then we get an unpleasant sound artifact. And on more stable sounds, like for example this low frequency sine, you would hear it even better. So this sound artifact is called a zipper noise. It happens because we change our amplitude of a signal very abruptly, which generates some discontinuities in the signal flow. And those discontinuities generate clicks. When we change it really fast, we have a lot of clicks and they sum into this zipper noise. We don't want that, and for solving this problem, we need some special smoothing, interpolating algorithm for our amplitude values here, which we change for multiplication of an input signal. But before going really there, I want to show you visually what means a discontinuity in a signal. So I open this edit mode of our Max4Live device and introduce you a new object which is called live scope, which visualizes an audio signal in time domain, just like that. So it basically shows the waveform of it. I connect to one of those outputs, for example, for the left channel, and I just play back here the sound. The cool thing that actually, although we're in editing mode, we can still get the signal here and try things out. That's really great. So now when, for example, I change from -4.3 to 0 very abruptly, then you hear the click, and also you could see here very fast change in the signal. If I do the same again, big jump, we hear even stronger click. So the bigger jump, the stronger the click, because the waveform has in this moment some kind of an imitation of a impulse waveform, which basically generates this click. And when we, for example, modulate really fast this gain control, then we have a whole sequence of those little discontinuities in a signal, and this generates for us this zipper noise. We don't want that, and to solve this problem we have, of course, a special algorithm, which is quite simple and involves linear interpolation. So first of all, we need to create some linear interpolation, and for that we can use a line tilde object. Linear signal ramp generator. That's exactly what we want. And to control this linear signal generator, this object, we would need another object which is called message. Basically, it lets you create any message for any case you want. You could also use this message, for example, to control the volume of our input signal by sending it in multiplication object. It would also work, for example, here when we send this message into line for controlling it in particular way. And all objects have some ways of controlling them with help of messages. We can look it up when we hold Alt and click on this object. We get this max help file, which shows all things which you need to know about this object. the most detailed information about the object. And here on the right, you can see in the reference all the messages which you can use for controlling this object. So for example, now I want to create some linear ramp, and I want that it starts from 0 and then it reaches 1 in 1 second, so in 1000 milliseconds. If I do it like that, then I can actually generate a linear ramp from 0 to 1 in 1 second. I want to connect it to live scope to also visualize it. Then I just log the patcher and then press on this message to send it into line object and let it generate this thing for us. Oh, beautiful, right? Then we could even improve it and go back to 0 from 1, also in 1 second. And you can notice that I have comma only here. And it means that just before comma, we need to write the initial value, and then we go from this initial value to all these interesting paths which we are ready here to create. We could also write here 0.5 in 5 milliseconds after 0, and then it would be something like that. And then it stays there on 0.5. We could even create another object number with tilde to be sure that this is really 0.5, and it is. But there's another way actually how we could interpolate between values linearly with help of this line tilde object. So for that we create another message. You could create very quickly a message just by pressing M on your keyboard and writing down here $1 and then, for example, 500. Nice. So now I just connect it like that, and in the lock mode, if I press here, we just interpolate to 0 in 500 milliseconds. Why 0? Because, well, $1 wasn't specified. $1 is like a replaceable argument, and it means probably it's 0, so it just jumps to 0 in 500 milliseconds, and now nothing changes. But if now I would connect to this message object the output of this expression, which just converts from dB to linear scale our values from gain knob, then we would be able to jump from our amplitudes value with some interpolation. So like that, like that. We have all this interpolation in 500 milliseconds from previous to the next value. And what we have here is actually always a new message. We can see what message is generated here by creating another message object and connecting the output of this message to the second inlet of this message. So let's see, to 1 in 500 milliseconds to nearly 0 in 500 milliseconds. And then we don't have anymore this zipper noise, because you can see when I change the gate knob, it creates this beautiful smooth curve. And of course 500 milliseconds is quite long. It would sound quite interesting if we would save this patch and try to use it. So maybe on the sign it's not that clear. Well, maybe it is. Let's just play back. Just a second. We still have zipper noise, of course. We need now to connect the output of line to the multiplication. So we don't need anymore it like this. We need it like this. Save and close. So it's really lazy changing of volume, because 500 milliseconds is quite long, and we always have this interpolation of 500 milliseconds, which is quite analog by its character, I would say. We could improve it to make it more instant. Just remove 1 0, make it in 15 milliseconds, save it, and then it's now good, and we have no more zipper noise. We could even make it smaller to 20 milliseconds. This is already a question of taste, how fast you want to have this interpolation, and I leave it for you. You can decide by yourself. So that's basically what we should do to this zipper noise and be more smooth and beautiful in amplitude change of our signal. And this kind of algorithm, this connection of $1 and some 50 or whatever it is with a line tilde object, this is a very basic structure, basic combination of objects which you would use in many situations in your Max programming. So I really recommend you to remember it. And also, one last thing I might say, that messages and signals work on different rates. This also kind of creates, in a way, problem and all those discontinuities. And so that just you know, signal rate, this is something which is equal to your sampling rate, for example, in the DAW. So in this case, I have 44,100 sample rate. And it means that in 1 second of audio, I have 44,100 samples. While in message domain in Max, you have maximum 1,000 messages for 1 second. So it's quite slower, which is still enough, still good. But messages are not needed to be that fast as audio signals, of course. And if you want to control an audio signal with messages, then you would need to create some kind of interpolation, like in this case we did right now. So I hope this lesson was helpful for you, and thank you for watching, and we will see us next time. Bye bye.